My name is Stanford Gibson. I am the Sediment Transport Specialist at HEC, and this is the second part of a three-part video series. In this video, we're going to create a RasMapper terrain of a semicircular flume. The first part showed how to create a semicircular flume in 1D, which we'll use in this part to actually create the terrain. And the third part will actually use this flume to run a non-Newtonian mud and debris flow simulation through the flume. The flume we're simulating is from the 2000 paper Parsons et al., where they ran a series of these high concentration debris flow flume experiments through a 14.6 centimeter diameter semicircular pipe. And so we're going to demonstrate how to create a two-dimensional terrain out of that pipe, and then in the next video we'll actually run the simulation of that high concentration non-Newtonian material. So in the description of the video you'll find the starting files. All you have is a project and a geometry file, which we created in the previous video. The geometry file is very simple. It has a reach that's georeferenced from 0 meters to 10 meters and two georeferenced cross sections that are each semicircular cross sections. And so what we're going to do is just take essentially these two cross sections that are georeferenced 10 meters apart from each other and create a terrain. So to create a terrain in RAS, we're going to go to RasMapper. RasMapper, you can either go to GIS Tools, RasMapper, or you can press the RasMapper button. And you can see in the tree over here, under geometry, we have the plus sign, which means there's something under there. And if we expand that, we can turn on the geometry and then turn on the river and the cross section. And if we zoom out, you can see here is our geometry data from our geometry editor. And so what we're going to do next is we're going to create a Geotiff, which is a raster digital elevation model, which RAS can then read in as a terrain. So in order to create the Geotiff, we're going to right-click on the geometry. So I'm one of the developers on the HEC RAS team, and I sometimes have trouble finding where things are in RasMapper. And so I have a general rule of thumb. When you're looking for something in RasMapper, right-click on the tree. And you might have to right-click on a couple of different levels of the tree if you've forgotten where it is. But if you right-click on the tree, you'll generally find what you need. And so we're going to right-click on the geometry file and go down to Export Layer. And we're going to choose Create Terrain Geotiff from Cross Sections. Now, we can do this with the channel only or with the overbanks in the channel. It doesn't really matter because we have no overbanks in this model. And so I'm going to select that, Create Terrain Geotiff from Cross Sections Channel Only. That's going to give me a dialog where I asked to enter the name of the Geotiff. So we'll call this Experiment 1A. The paper has a number of experiments. The experimental paper has a number of experiments, and then the numerical paper that we put out that accompanies these videos modeled 10 of those. We're just going to do one of them in this video, Experiment 1A. And so then it asks us for a raster cell size. Now this is where the peculiarities of dealing with a flume come into play. Generally, when you're dealing with a prototype simulation, you're looking at cell sizes on the meter scale. But since we're dealing with essentially a 15 centimeter diameter flume, we're going to want to have a really small raster size. And so I've actually gone with a raster cell size of 1 millimeter. This is almost certainly the smallest cell size that you'll see, but with flumes we often need a tighter resolution. And so I press OK. It takes a little while to generate, but not that long, and so we've generated a Geotiff. But you'll notice that down here in terrains, nothing's been added to RAS. RAS hasn't automatically added that Geotiff. We have to go in and add it. And actually, we're not just going to add it, we're going to create a new RAS terrain. The Geotiff isn't actually a terrain. RAS is going to create an HGF5 file out of the Geotiff. So even though it seems a little bit counterintuitive, like you're making this thing twice, you're going to choose the create function to create a terrain out of the Geotiff. And so it asks us if we want to reference it in space, and since This is georeferenced, but it's kind of arbitrarily georeferenced, so this doesn't actually exist anywhere in the world. If we were to try to plot a Google Earth plot behind it, it would probably be in the middle of the ocean. We're going to say no. And that gives us the terrain layer creation editor. So the first thing we're going to do is we're going to push the add button, because that's going to allow us to add the geotiffs we want. You can add multiple geotiffs. You can add multiple geotiffs and you can stitch them together, but in this case it's very simple. We're just going to add this tiff that we made. And then because this is so small, we want to make sure that there's no rounding, and we want to turn off the stitches. And then since the terrain gets a default name of terrain, which isn't very helpful, I like at this point to go in and rename it. So you press this folder button, and this will give you the opportunity to change the name to Experiment 1A. So now the terrain has a more intuitive name, and then you press Create. RasMapper creates the terrain, tells you it's complete, close, and now it's been added. And so now, if we zoom in, what you'll see is that we have actually created terrain with the cross-section data that we gave Ras. But what we want to do now is test it, is make sure that this terrain actually looks the way we expect it to. And so to do that, I'm going to go to Profile Lines, this third tab down here. And if I press the plus button, it'll let me create a profile line. You'll get these little crosshairs. And I'm just going to draw a line across the flume. And then I'll click Save, and it'll ask me to give it a name, and I'll say Test Cross-Section, because that's what I'm going to do. And now I can right-click on Test Cross-Section and say, hey, plot a profile. And actually, we don't have any results yet, but I just want to plot the terrain. And so this is the cross-section of the terrain we created. You can see that it's got good resolution, it's symmetrical, and at the right aspect ratio, it is in fact semicircular. So then we want to right-click on geometries and make sure that the terrain is associated with the geometry data. It is. So then, if we go open the geometry data, sometimes you have to turn it on and off. You can see that now we have the terrain associated with the geometry data, and we're ready to build a two-dimensional model. All right, that's all we're going to do in this video. We have created the terrain. Now we're ready to add boundary conditions, add flow, and add non-Newtonian parameters to actually simulate this event. As with the other videos, this work was funded by the U.S. Army Corps of Engineers Flood Risk Management Research and Development Program, and in particular the Post-Wildfire Flood Risk Management Work Unit in that program, which is headed up by Ian Floyd, who is a co-author in this paper, as well as Ronnie Heath and Alex Sanchez. This video is in a draft form, while the companion paper is in review. Feel free to leave comments on how it can be improved, and we will post it to an official site once the paper is published.